Today you are asked to create a chart of perfect squares. Please have this next to you as we fill in the notes on the topic of square roots and cube roots. So the first thing you need to do is write your name and then open up to the inside. Here you see some key vocabulary terms that we need to know when talking about and learning about square roots and cube roots. The first is the radical sign. This looks very similar to a division sign, only it has a little curved edge to it now. The next is the radicand. This is the number inside of the radical sign. In my example, it is the number 81. The index is the number attached to the radical sign, meaning right here in our example, it is the number 2. This number tells us how many times we need a number to be multiplied by itself to get the answer, or the radicand. Lastly, we have the root, or the solution. This number cannot be a fraction or a decimal, and this is the number that we multiply. So in our example, 2 times. Because of that 2, we know that this number, something times something, needs to equal 81, and that is number 9. If I open up to the middle page, it's talking about the square roots. And our perfect squares that we drew today, any number that tells us the area is the perfect square. So if I were to count each and every one of these boxes, I would find that the area is 16, or I could write it equals to the square root of 16. Here I have added the number 2, but you can write it with the 2 or without the 2. It means the same thing. So the square root of 16, in order to find that, the solution is the side length. Here the side length is 4, and that is the solution. So the square root of 16 is equal to 4. Here the area is 9. And the side length of this shape is 3. That is the solution. Here, it would be the square root of 4. We have 4 boxes, or the area is 4. The side length is equal to 2. And last but not least, this last one is equal to the square root of 1. Don't let it confuse you. There's only one box here, and that means the side length is equal to 1.